This lesson covers compound interest and applications. Compound interest. If an initial principal, P, is invested at an annual rate R and the interest is compounded n times per year, the amount A in the account after T years is A of T equals P times 1 plus R over N raised to the power of NT. And here we are talking about money, for example, in a savings account. Or you could use this formula to determine the amount owed on a credit card balance that goes unpaid for a period of time. Let's look at an example. If Ted invests $5,000 in a CD at an annual interest rate of 3.45% compounded quarterly, how much will Ted have in his CD at the end of 5 years? We'll start with the formula. A equals P times 1 plus R over N raised to the NT, and we're solving for the amount that Ted will have at the end of 5 years. So we're solving for A here. The principal, he starts with $5,000, so that will be our principal. The interest rate, R, is 3.45%. I want to write that as a decimal, as 0.0345. N is the number of times that interest is compounded per year. Here it is quarterly, which means that N will be equal to 4. And T, the number of years, is 5. So let's plug in all these numbers. I have A, the amount Ted will have at the end of 5 years, is equal to 5,000 times 1 plus 0.0345 divided by 4 raised to the power of 20. So I'll plug this in a calculator, and that will give me the solution that Ted will have $5,936.97 in his CD at the end of 5 years. How much will Sandra need to set aside now from her $4,500 tax refund to have $4,000 for a dream vacation 3 years from now? She will be investing in bonds that have an annual interest rate of 9.7% compounded semi-annually. We'll use the same formula, but this time, note, we're solving for P, the amount that Sandra needs to invest now. We know that the amount she wants to have at the end of 3 years is $4,000. So $4,000 here will be A. R, our interest rate here, is 9.7%, which we will write as 0.097 in decimal format. And N, the number of times that interest is compounded per year, semi-annually means that N will be equal to 2 here. T, the number of years, is 3. Okay, so let's plug in all these numbers. We have 4,000 equals P times 1 plus 0.097 over 2 raised to the power of 6. And I want to isolate P here. I can do that by dividing both sides of my equation by 1 plus 0.097 over 2 raised to the power of 6. Dividing 4,000 by a quantity raised to the power of 6 is the same as multiplying 4,000 by that quantity raised to the power of negative 6. So I will solve for P equal to 4,000 times 1 plus 0.097 over 2 raised to the power of negative 6. I find that Sandra will need to set aside $3,010.57. Try on your own. If Sandra decides to invest her $4,500 tax refund at an annual interest rate of 9.7% compounded semi-annually, how much money will Sandra have after 10 years? So this is assuming that she invests her entire tax refund.